Welcome to the 10th example in review of statics. The question reads, the component beam is fixed at point A and supported by rockers at points B and C. There are hinges or pins at points D and E. Determine the components of the reaction at these supports. Okay, so we start with givens, and we are actually given some important notes in this question. And namely, let's zoom in on the diagram. It says that the beam is fixed at point A, right? And what that basically means, that tells us that we're going to have an x component or a y component, so AY. We're going to have an AX component, but we're also going to have a moment, right? We're going to also have a moment. So we have to take that into our consideration in our free body diagram. It says that we have hinges or pins at D and E as normal. So we have a y component and an x component for both of them. And then at B and C, while these things may look like pins, they are rockers. And a rocker actually has just one specific y component. It doesn't have an x component, right? So that's very, very important in our calculations later on. So we're going to write all of that good stuff down. So we're going to say we have rockers at B and C and C. We have pins at D and E, and we have a fixed connection at point A. Perfect stuff. We are going to move on to unknowns. In terms of unknowns, this is going to be a long question. Basically, it wants us to find everything, you know? It wants us to find the reaction forces, the reactions, basically, at points A, points B, points C, points D, and you guessed it, point E as well. So it's going to be very, very fun. We also can move on now to our free body diagram. And this lovely thing is going to look like so. And if we label the points quickly, A, D, B, say E is over there, and then, we'll say C is over here. We can do the dimensions. And then we also need a section right there. This is 6 meters, this is 2 meters, 2 meters, 2 meters, and then also 6 meters. We can put the external forces, or the apparent external forces. And we have 15 kilonewton right there. We also have a moment, actually. So let's also add this counterclockwise moment at point C, so 30 kilonewtons per meter. And now we can add our reactionary forces, or our basically reaction forces from the connections, and I'll put that in this rose color. So remember, it's a rocker connection, so we're only going to have CY. This is a pin connection, so EY, EX. A rocker connection again, so BY, DY, and DX. And then at A, we have AY, AX, and a moment A. Perfect. Okay, so what are your next steps from here? I think we have everything. We have everything. Are you going to take sum of forces or sum of moments or something like that? Well, yes, you are, but it would be much easier, or you should basically section the beam now. Because let's say you do take sum of forces in the y direction. You have like almost 10 unknowns here. So that's not going to be fun. But what you can do is you can section the beam and then go like section by section, and for example, find EY, EX, and then go on to the next section. You have EY and EX, you can use them to find BY, and then just basically go through the beam. This question specifically, we're going to split it up into section CE, analyze this section, section DE, and then section AE, or section AD. So that's how that's the game plan for this question. And then basically the stuff we've been doing for a while now, and that's basically just sum of moments, sum of forces, and all that fun. Okay, so we'll start with section, let's start from the right, so section CE. It's going to look kind of like this, and then you have points E, points C, you have your forces EY, EX, CY, and a 30 kilonewton moment, or kilonewton times meters. This in its entirety is 6 meters. And then now you should know, you can simply find, I won't even I'll just run through it. If you take a moment about E, what are you going to get? You can find CY. Why? Why can you find CY? Wow, pretty cool stuff. Because EX cancels out, EY cancels out. You have CY, and you also have to take into account 30 kilonewtons times meters, right? What's your equation going to be like? It's going to be the sum of moments about point E is equal to 0. You have a counterclockwise moment, and if we say counterclockwise moments are positive, you have 30 kilonewtons, right? Kilonewtons times meters. Plus, is CY going to cause a positive moment or is it going to cause a clockwise moment or a counterclockwise moment? Well, it's going to cause a clockwise moment, or a It's going to cause a counterclockwise moment, and that's basically CY. What's the distance? 6 meters. If you isolate for CY, you're going to get the CY is equal to -5 kilonewtons. That basically means we misrepresented the direction. So CY actually acts like this, right? Perfect stuff. What are we going to do? We're going to put down our given value. So we know that CY from that moment sum is equal to -5 kilonewtons. So basically, I'll keep it the same, but like if you see a negative, that means it actually acts in this direction. Perfect. Now we take sum of forces. We take sum of forces in the y direction. What do we have? We just have EY and we have CY, right? We're going to have CY plus EY. CY is equal to -EY, and therefore EY is equal to 5 kilonewtons. Sum of forces in the x direction, you get that EX is the only force that is there, and I keep forgetting this, I apologize, but our coordinate system is like this. But from that summation of forces in the x direction, you get that EX is also equal to 0. Perfect stuff. And that is your answer for EY and EX, so your reactions at point E, and this is your answer for your reactions at point C. So perfect. We have, I don't know, not half the answers, but we're getting there, yeah? Okay, we can move on to the next section now. What did we say? We're going to look at section DE now, okay? Perfect stuff. So we'll draw it right here. So section DE. We're going to analyze the forces in this section and the moments. If we draw, let's use this color. This is going to be point D. This is going to be point E. Point B is going to be around here maybe. And then let's put the dimensions on there. Let's say the 15 kilonewton force is around here. So this is 2 meters. This is 2 meters. This is 2 meters as well. Did I get that right? I think I did. Perfect stuff. We add our 15 kilonewton force. We add our BY force. We add our DY and DX force. Now, a very, very important point. If you were to do this, EY and EX, okay? This is not right, okay? Because basically, it's not right if you use the same value you got from CE. Because basically what we're going to do, at this point, we know what EY is, right? Because we found it in this part of the problem. But if we take a zoomed in section, if we cut this beam open, and you look at it like this, so let's say we section the beam, right? Or let me actually move it a bit like this. So let's say this is E on the left side, and then this is point E on the right side. On the right side, right? We did the right side, right? So we said EY acts like this, and then EX in our theoretical scenario acts like this, even though we know it's 0. If I look on the right, on the left side, it's going to be equal and opposite. If on the right side, EY and EX are positive, that means on the left side, when I analyze the left side of this point, when I section the beam, when I cut it, EY has to be negative on this side. And EX has to be also negative on this side. So I have to take that into account. I can't make both of them positive on both sides. That doesn't make sense. It's not an equilibrium, right? So on the left side, it's negative, and on the right side, it's positive. Hopefully that made sense. So we're going to say EY acts like so, and then EX acts like so. I know the value of EY. I know the value of EX. Let me keep that in mind. Perfect. Again, I'm going to run through the same jazz. I'm going to take the sum of moments about point D, get rid of dx, get rid of dy. This will cause a clockwise moment. This will cause a counterclockwise moment. And this will cause a clockwise moment, right? EY will cause a clockwise moment. This will cause a counterclockwise moment. And this will cause a clockwise moment. I'll quickly write that in this magic pen thing. I'm going to get, again, negative 15 because it's clockwise times a distance of 2 meters plus by times a distance of 4 meters minus EY, which is basically 5 kilonewtons, as we've established up here, times a distance of 6 meters. Okay. What is this going to give me? I have one equation, one unknown. Remember, I know EY. I can find BY, and from that, you will get that BY is equal to 15 kilonewtons. Okay, you take the sum of forces in the y direction, you take the sum of forces in the x direction. You know EX is 0. If you take the sum of forces in the x direction, you're also going to get dx is 0. If you take the sum of forces in the y direction, you're going to get that dy is equal to 5 kilonewtons. Perfect. We have one last section to cover, and that is the section AD. So 6, section AD. Let me zoom out to keep this in frame. This is your point A. This is your point D. Dimensions, 6 meters. You have your forces, again, same concept as last time. It's going to be opposite, so dy dx, and then we said we have ay, ax, and then a moment about y, or about a, or about, yeah, about a. Perfect stuff. Okay, now, again, the exact same thing. If we take a moment about A, what are we going to have? Sum of moments about point A, counterclockwise, is positive. We're going to have, we made this moment right here positive or negative. So we're going to say negative MA because we say counterclockwise is positive, but that moment is clockwise. So it's negative MA. What other forces will cause a moment? You also have a negative moment caused by dy. So you're going to say minus dy times 6 meters. Okay, one equation, one equation, one unknown. Your unknown in this case is MA. You already have dy. You found it up here. You're going to get that dy, or my bad, you know, you're going to get that MA is equal to 30 kilonewton meters. If you take a sum of forces in the y direction, you're going to get that AY is equal to 5 kilonewtons. And you're going to get the AX is equal to 0 kilonewtons. And those are your final answers. You've basically, I'll write them down, but you have basically found all the reactionary forces and moments that the question has been asking for. So 5 kilonewtons, and then AX is equal to 0 kilonewtons.